Hi everybody, today we're looking at something called the modulus function. And the modulus of x has a two-part definition. Now the two-part definition says that if x is, so we're taking the modulus of x, if x is a positive number or 0, we don't do anything to it. It's just that number. Or the other way that I've formally shown it is we multiply it by 1, so we just get x. Now, if it's a negative number though, that's when something happens. That's when we multiply it by minus 1. So let's have a look at how it works. So it's this two-part definition. So the modulus of 3, well 3 is a positive number, so nothing happens to it. No, I don't want to write in highlighter. So the modulus of 3, well, we could say it's 1 times 3, but that's just 3. In other words, if it's positive, just leave it alone. It is what it is. The modulus of 3 is just 3. Now, it's when it's negative that something happens. So the modulus of negative 5, now negative 5 is a negative number, so we're going to multiply it by minus 1. And so minus 1 times minus 5 is just positive 5. So what it's done is it's taken a negative number and it's made it positive. Okay, let's have a look. Modulus of 0. Well, 0 is part of the bit where we leave it alone, so it's just 0. And then the positive of negative a when a is greater than 0. So if a is greater than 0, then negative a is less than 0. And so it's part of that bit where we have to multiply it by minus 1. So it'll be minus 1 times minus a. Two negatives give us a positive, and so it will be a. Okay, so what really is what is happening, so in effect the main purpose of the modulus is just to make negative numbers positive. So all it does is it only affects the negatives and it makes them positives. If something's positive, it doesn't change it. So perhaps we'll just put that here, that it doesn't change positives or positive numbers. Has no effect on them. Now, there's a bunch of properties about the modulus that we'll explore in lesson, and the particular ones that I want to explore is, well, that one we've already talked about. It makes negative numbers positive, and it doesn't change the positives, so any modulus will either be 0 or a positive number. We'll talk about this one in class, so perhaps I'll highlight that in a different colour, but we'll talk about that one in class, and this one, and this one. We'll talk about these, one of those, and 8 will come up later. But we will talk about some of those. Now 2, 3 and 4 are fairly straightforward. 5 and 6 require a little bit more work to think through. Okay, alright, so let's have a look at how we can solve modulus equations. So that's an equation, something with an equal sign, that actually has a modulus in it. So let's think first of all about, let's say we know that the modulus of x is equal to 5. Now, if this is the case, then two things could have happened. Either we're doing the modulus of 5, and so x equals 5, and so then when we did the modulus of 5, the modulus told us to leave it alone because it's a positive number, and so we just got 5. Or x could have been negative 5, and so when we did the modulus of negative 5, the modulus told us to multiply it by minus 1, and so we just got 5. So if the modulus of x was 5, then there is two possibilities. Two options, if you like. X can be 5, or x could have been negative 5. more generally, what we say is if the modulus of some function or some expression involving x is equal to k, where k is positive or 0, then f of x could have been the positive or the negative value of k. Both of those under the modulus would have given us k. So there are two options. Okay, alright, so what we're going to do first of all is whenever we solve a modulus equation, we're going to rearrange it to get it into the modulus of the expression equals a number. So we deal with the outside bits first. So I've got minus 2, modulus of 3x plus 6, modulus plus 2 equals minus 10. So we're going to deal with the outside numbers first. That I've added in what that actually means. It means we've got to rearrange it to the form the modulus of some expression in x equals k. So I'm going to, using my equation solving techniques, I'm going to move the 2 over first. So minus 10, and that's going to be take 2 is going to give me minus 12. And then I'm dividing both sides by minus 2. That cancels. So the modulus of 3x plus 6 equals 6. Now the second step is to move the modulus and change the number to plus or minus that number, as we were talking about before. So that means 3x plus 6 is equal to plus or minus 6. Two equations, which we're going to have to solve. So 3x plus 6 can equal positive 6. And 3x plus 6 could equal negative 6. They're my two equations, and if I solve them here, if I take 6 from both sides, I get that 3x equals 0, so x equals 0. That's one solution. And here, 3x, well, if I take 6 from both sides, I get minus 12, so x is equal to minus 4. Just before we finish, we've got to check both answers, because you can actually get a wrong answer, and we'll see why later when we're actually graphing. But so let's check it. So if I substitute x equals 0 into my original equation, and it's good to do it into your original equation, well, I'm going to get 3 times 0 plus 6 plus 2. So that'll be minus 2 times by the modulus of 6 plus 2. So it'll be minus 2 times 6 plus 2, which is minus 12 plus 2, which is minus 10. So that's correct, that figures. And then if I go across to this one, well, let's check that one. So it'll be minus 2, 3 times minus 4 plus 6. And I should just take that off, plus 2. So it'll be minus 2. Now 3 times minus 4 is minus 12. Minus 12 plus 6. So minus 2. Minus 12 plus 6 is minus 6 plus 2. Taking the modulus of minus 6 will give us positive 6. So it'll be minus 2 times positive 6 plus 2, which is what we had before, which is minus 12 plus 2, which is minus 10. So both the answers work in this case. Okay, solving x plus 1 equals minus 2x plus 5. Alright, now we said deal with the outside bits first, so we get the modulus of something equals a number. Well, in this case we don't have a number, but we can still deal with it the same way. And on the left hand side there's nothing outside the modulus. Now, PM stands for plus or minus. So, x plus 5, so we remove the modulus, will equal to plus or minus minus 2x plus take 5. And so I'm going to get my two equations. So x plus 1 is equal to minus 2x plus 5, the positive, minus 2x take 5, the positive of that. And x plus 1 will be equal to the negative of minus 2x take 5, which tells us that x plus 1 will be equal to 2x plus 5. Okay, so we're going to go through and solve both equations. So I'm going to get all my x's on one side and all my numbers on the other. So if I add 2x to both sides, I'm going to get 3x. And if I take 1 from both sides, I'm going to get minus 6. So x is equal to minus 2. Here, if I'm going to take x from both sides. So that will give me, if I take x from both sides, that will give me x on this side, and then I'm going to take 5 from both sides, so that's going to give me minus 4 on that side. Okay, so now I check. Well, the modulus of x plus 1 is going to be the modulus of minus 2 plus 1, which is, now minus 2 plus 1 is just minus 1, so it will be the modulus of minus 1, which is just 1. Now I need a bit more space. So it was minus 2x take 5, so if I do minus 2 times minus 2 take 5, minus 2 times minus 2 gives me 4, 4 take 5 is minus 1. It's not a solution. Let's check minus 4. Minus 4 plus 1 is minus 3. Modulus of minus 3 gives me positive 3. Minus 2 times minus 4 take 5 is going to be positive 8. Take 5 is 3. So minus 4 is a solution, and it's the only solution. So you sometimes get wrong answers, and so you actually need to check the solutions. Okay, solve. Now we're going to modulus on both sides. Now, we don't have anything outside the modulus here, so there's nothing to do with there. And if we brought them both to the same side, for example, if we had modulus of A take modulus of B, that's not necessarily the modulus of A take B. It is in some cases, but not in all cases, as we'll talk about in lesson. So, really, if we remove the modulus, we should put a plus or minus on both of them. So if I take away the modulus of 3x take 4, well, that means I could have had just positive 3x take 4, or I could have had the negative of 3x take 4. If I take away the modulus of 2x plus 3, I could have had the positive of 2x plus 3, or I could have had the negative of 2x plus 3. Now that leads us to 4 equations. It leads us to the equation 3x take 4 is equal to 2x plus 3. It leads us to the equation 3x take 4 is equal to the negative of 2x plus 3. It leads us to the equation that the negative of 3x take 4 is equal to 2x plus 3. And it leads us to the negative of 3x take 4 is equal to the negative of 2x plus 3. So that's 1. This is 2. This is 3. And this is 4. Now if I stop and think about it for a minute though, if I divided this by minus 1, so I divided both sides by minus 1, then I would get equation 2. So there's nothing actually different between 2 and 3. So 2 and 3 will give the same solution. Now, the same with this one. If I divide this one by minus 1, then I get 1. So this is unnecessary, and this is unnecessary. So I just need to solve 1 and 2. So you just need to solve the one where both are equal and the one where one side is negative. When you've got something, the modulus of something equals the modulus of something. So you don't need to solve all four. You just need to solve the one where both are positive and the one where one side is negative. Okay, alright, so taking 2x from both sides will give me x, adding 4 to both sides will give me 7. Okay, what about here? X take 4 will equal minus 2x take 3. Add 2x to both sides will give me 5x take 4 is equal to minus 3. Add 4 to both sides will give me 5x minus 3 add 4 will be positive 1. And so x is equal to 1/5. Alright, so let's check them now. So when x equals 7, the modulus of 3x plus 3x take 4, but make sure I've actually substituted into the right thing, is the modulus of 3 times 7 take 4, which is the modulus of 21 take 4, which is positive 17. Modulus of 2x plus 3 is the modulus of 2 times 7 plus 3, which is the modulus of 14 plus 3, which is going to give us positive 17. Okay. Okay, alright, so x equals 7 is a valid solution. What about 1/5? Well, the modulus of 3x take 4 will be the modulus of 3 by 1 on 5 take 4, which is the modulus of 3 on 5 take. Now 4 is 20 on 5, so that will give me minus 17 on 5. And the modulus of that will be positive 17 on 5. Okay, of 2x plus 3 when x is 1 on 5. Well, 2 times 1 on 5 will be 2/5. 3 will be 15 on 5. When I add those two, I'm going to get the modulus of positive 17 on 5, which will be 17 on 5. And so then x equals 1 on 5 is also a solution. Okay, so our two solutions in this case are 7 and 1 on 5. Okay, and we'll leave it there.